All right, hello everybody. It is another Math Man Monday, and today we are going to be doing graphing and linear equations. Last week we hit on fractions. We'll have a little pool going into next week with it being an ACT week coming up the following Saturday. We might have some things to discuss there, but we'll just kind of see how it goes. So to start off with graphing and linear equations, I'm primarily going to be focusing on different tools to use, especially with the ACT coming up, so people can get a better understanding of what to kind of expect and to help them on multiple choice questions. So I'm going to go over several different things here, but overall, keep in mind I am trying to spin this in a way that it would be helpful on standardized testing. So again, if you have questions, hit me up in the chat. If you're watching the VOD review or you're on YouTube, post something on YouTube, shoot me a DM on Twitter, figure something out. I got you. So to start off with graphing and linear equations, we need to talk about slope. And my good boy slope is also denoted by an M, and it has several different meanings. We like to think about it as rise over run. We like to think about it as change in y over the change in x. If you get into calculus, we talk about rate of change. All right, so we have several different meanings that come up here, all of which mean slope. So just to get that out of the way immediately, all of it means slope. And with slope, our actual equation that we're going to use, that way we have things not always written out in words here, we are going to be using y2 minus y1 over x2 minus x1. Now, let me preface this. If you want to have it as y1 minus y2 and x1 minus x2, be my guest. That is completely fine. You just need to stay consistent with what you're doing. So I always use the same labeling, but again, it's really up to you. It's a personal opinion on that. So before I get into actual problems, I want to talk about the different types of slope. There are actually 4 types of slope that we need to discuss. So we have types of slope. And to talk about the types of slope, we need to have 4 graphs. Okay, and with each of these graphs, we're going to talk about something slightly different for each one. I'll try to use green, that way this is kind of be able to see. So if we have it like this, if we have a graph like this, hopefully that's pretty visible. We have a horizontal line graph, and we have a vertical line graph. This green pin is pretty dead, so I don't know if we're going to use that too much tonight. Okay, so here we're looking that we're going upwards left to right. This is a positive slope. Things of that nature could just be y equals x, y equals 2x, however you want to look at it, but it's a positive slope. If we're going downwards left to right, like you're going downhill, this is a negative slope. Then we get over to the 2 that everybody kind of messes up. Here we have it as being a horizontal line. This graph is actually a y equals graph. So for instance, we could put some points on here and say 1, 2, 3, 4, and say this is y equals 4, just to give you a kind of an example of what that looks like. But not only that, when we're looking at this, we have to think about, we are running, we're not rising. So we actually, if we think about slope, we have 0 in our rise, but we just have a number in the bottom. All right, when that happens, 0 divided by any number is 0. So this is a 0 slope function. And last but not least, we have a vertical line. So we'll say 1, 2. We'll call that x equals negative 2 to give you an example of what a vertical line function looks like. But not only that, let's talk about the fact that the slope this time is a reciprocal of what's over here, where we have a rise, but we don't have a run. If you divide anything by 0, can't be done. It's undefined. I ask this question all the time in my pre-cal classes, in my college courses, and people mess this up all the time. If you have a vertical line, the slope's undefined. These are all really great tools if you're sitting on the ACT, where if they say, hey, match the function with the graph, all you have to do is look at the slope, which we're going to discuss in a second, and know that, okay, well, if it's positive, it should be going upward, left to right. If it's negative, it should be going downward, left to right. And then I have my horizontal and my vertical lines and their slopes. So that gives you kind of an idea of what to expect here. But let's look at some examples about how to solve for slope and then get to what a linear function kind of looks like. Or a linear equation, I guess. So we didn't talk about examples of slope there. We just talked about the different types of slope. So we want to say, in an example, find the slope given the points, how about 3, 7, and 4, -2. All right, we just need to remember that we had it as y2 minus y1 over x2 minus x1. So let's go ahead and write that out. Our slope is equal to y2 minus y1 over x2 minus x1. That way, when we go to do this problem, I always suggest that when you're starting off, if you're new to slope, go through and label these. Like, this is x1, this is y1, this is x2, this is y2. If you need that visual to help you starting out, or even if it's beyond that, take the time to do it. That's fine. There's nothing wrong with that. It's okay. No one's going to down you for doing that. Let's try to get a better angle for us here, but I think that's as good as it's going to get. So we go through and we say, hey, we have our y2, which is -2, minus our y1, which is 7, over x2, which is 4, minus our x1, which is 3. -2 minus 7 is a -9. 4 minus 3 is 1. You can leave it as -9 over 1, but you can also just take a second and say, well, hey, that's the same thing as -9. All right. It doesn't matter how many different problems you do like this. Whoa, that was bad. Sorry, peeps, that was not good. Whoopsies. If you do the same type of example here, as my pen's not open and I'm trying to write with it, everything just went wrong in that one moment. We could do the same type of example. So keep everything the same, and we change our points. So let's talk about -2, -5, and 11, -8. All right, keep the same idea that this is x1, y1, x2, y2, and we can go over here and say, okay, well, again, let's solve for our slope. So we're going to say, okay, well, we have y2, which is -8, minus y1, so minus a -5, all over x2, which is 11, minus x1, which is a -2. I'm writing it out this way to make sure that we understand that you need to go through and change the signs. So -8, this becomes -8 plus 5 over 11 plus 2. All right, -8 plus 5 is going to be a -3 all over 13. So again, these answers are okay. My -9, -13 over 3. Perfect. Nothing to worry about there. This leads us into our different types of equations that we're going to use. And there are actually 3 types of equations that we're going to talk about. If you have a question, let me know. Always feel free to ask in the chat. I can always take a moment during the lesson or even after the lesson and take some time and answer some questions. But hopefully so far, besides the camera crashing, we're doing all right. Okay, so we have our different forms. Different linear forms. Okay, we have what is known as general or standard form. And general or standard form is what I like to call the most useless of the forms, but if we take some time to actually pull information from it, we can. So that is when we take ax plus by and set it equal to c. All right, then we have point slope form. And with point slope form, that's when we have y minus y1 is equal to m times x minus x1. And I'll make some more notes next to these in just a second. And last but not least, the end all be all, the thing that we want, slope intercept form. And with slope intercept form, that's where you have y is equal to mx plus b. Okay, so let's talk about each of the forms here. In standard form, they usually want you to find an x or y intercept. So usually what we're finding here is we find x and y intercepts. All right, that's as simple as, I like to just say it's really substituting a 0, but to make it easier, if you want to know x, then you cover up y, your by, and say ax is equal to c. If you want to solve for your y, you cover up the x term and say by is equal to c. Bam, you now have an x-intercept and a y-intercept. What generally isn't found from here is you can actually find the slope. And to find the slope, your slope in this with general form is going to be equal to negative a over b. And that's because if you solve this equation out for slope intercept form, in other words, you solve for y, you end up getting, you'd move your ax term over, you'd divide by b, and you'd end up with this anyway. So just to cut out all that legwork, you can just find the x and y intercepts by covering each of them up. And there's a little formula for slope just to make life easier. Our goal in point slope form is solve for y. Well, guess what happens when you solve for y? You get slope intercept form. Last but not least, in slope intercept form down here, we know m is the slope and b is your y-intercept. Hence, the reason it is called slope-intercept form. If you're going to use point-slope form, they're giving you a point and a slope, or they gave you 2 points and asked you to find the slope. So these are the different things you can kind of see as far as linear forms. They really like to give you these two, and then have you go back to general, or start with general and find an x-y-intercept, and then change that to be slope-intercept form. Generally because they're asking you to find the slope, which we can use this little formula for. So let's talk about a couple different things. We can do an example of, over here, find the x and y intercepts. So let's talk about, what if we had 3x plus 6y equals 24. Okay, in this case, you'd substitute, if we want to know our x-intercept, we'd substitute 0 in for y, and it'd leave us with 3x is equal to 24, which means x is equal to 8. Congratulations, that's an x-intercept. If you go and graph it in a graphing calculator, or even if we graphed it by hand, you're going to see that. Then we come over here and we say, hey, well, we do the same thing. 6y is equal to 24. So y is equal to 4. Now, this doesn't mean much to us in the sense of like these are just numbers. We've found the x and y intercepts. If we wanted to find the slope, m is equal to negative 3 over 6. So we get negative 1 over 2. I'm writing that out so we can look at a couple things here. Let's talk about what it means to graph this with the x and y intercept. The most basic form of graphing that they mentioned to us at the beginning is that we can use x and y intercepts. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, and 7. Okay, all we're going to do here is we're going to go over 8 terms for x. 1, 2, 3, 4, 5, 6, 7, and 8. We're going to place a little point right there. Then we're going to go at where y equals 4. 1, 2, 3, and 4. And we're like, oh, hey. And we play connect the dots. And we just come over here and bamboozle. We have a line. All right, that's the most basic form of graphing that they give you from general form. And it's really easy. But we can also look at this is a negative line, right? Our slope is negative, so it makes sense that we're going downwards left to right, so it's a negative line. As long as we go left 2, 1, 2, and then we went up 1, and left 2, 1, 2, up 1, left 2, up 1, left 2, up 1. We get back to that point. So we could keep using that slope. I always like to tell people, if you can count, you can graph. It's something that people struggle with, but all you have to do is be able to count points. So for these general linear forms, we can always just count, and we should be able to graph them. This leads us into if we're given a point and a slope. So if we're given a point and a slope, so we have another example. We say, find a line passing through negative 3, 1, and has a slope of m is equal to, we'll keep it fractionless this time, let's say a negative 4. Okay, we have over here, we have a x1 and a y1, and we have our slope. So we have the piece of information we need. If you don't remember from the previous page, we said, okay, when we're given this point and a slope, we're going to use point slope form. So if we don't remember what that is, I'll write it out here. It's y minus y1 is equal to m times x minus x1. And we're going to start substituting that information in. We're going to go through and we're going to say, hey, well, what is y1? What is x1? Well, y minus y1 was 1 equal to negative 4x minus a negative 3. All right, again, I know you probably know how to change the signs, but just in case, I'm doing this the long way so we can kind of work it out. That means over here we have y minus 1 is equal to negative 4x plus 3. I like to go ahead and do this in one step over here. We know we're going to have to add this 1 here and add 1 here. So we can go through and say, okay, well, end up with y is equal to negative 4x. Negative 4 times a positive 3 is hopefully negative 12. And we have a plus 1 at the end. So finally, we have y is equal to negative 4x minus 11. Let me get that on the screen. Okay. You could definitely do this in less steps. I just want to make sure that we see every little detail that we need, at least for the first one. Okay. With that happening, we can come over here and we can graph this again. When I made this problem, I didn't really think about how far down it would be on the y-axis, but that's fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, and 8. All right. So we're going to use our blue marker. We're going to put a point down here at negative 11. And then we know it's a negative slope. We need to go, you have to pick one negative direction. We're going to go left. So up 4, 1, 2, 3, 4 over 1. And then we're going to go 1, 2, 3, 4 over 1. And then bam, that's our graph. All right, that wasn't very hard for us to do. Pretty straightforward and simple. We can talk about a couple other things that happen here. They could make this slightly more difficult and say, hey, given 2 points, find the slope and then find a line passing through them. That's not anything different besides you have to do y2 minus y1 over x2 minus x1 at the beginning. And then you pick which point you want to use. But notice we started off with point slope here. That's point slope. And we ended with slope intercept. So there's not a lot of reason to talk about, oh, what happens with slope intercept? They just ask you to graph. They'll say, hey, what's the slope? What's the y-intercept? Graph it. The good thing about this is we're going to talk about something else that goes along with this. We're going to talk about parallel and perpendicular lines. All right, so sometimes they'll say they want you to find parallel and perpendicular. So we need to talk about parallel and perpendicular. Might help if I spelled parallel right. All right, so with parallel, we want to remember there's actually a notation to go with this that kind of looks like this. Looks like 2 lines next to each other. Parallel have the same slope. And then perpendicular gives you a notation that's sometimes written like this. Have opposite, as in sign, reciprocal, which if you don't know what that means flip slopes. We see a couple different things about this where let's write a quick example here. Are the following slopes parallel perpendicular or neither? All right, and they'll give you, we'll give ourselves a few examples, A, B, and C at least. All right, so we have an M1, and we'll have that be equal to -4, and then we'll have M2 be equal to 1 over 4. And then we'll have M1 be equal to 2 over 3, and M2 equal to -3 over 2. And then here we'll have M1 is equal to 6, and M2 is equal to -6. All right, so we're asking ourselves, are they parallel, perpendicular, or neither? In order to determine that, we look at their slopes. Here, I have a -4 for my first slope. My second slope is 1/4. Well, we have to remember perpendicular means they have opposite signs and they've been flipped. Well, are the signs opposite? Yeah, they are. We have a -4. Here we have a positive. Technically, this is 4 over 1. So it's also flipped. So this is perpendicular. Over here, I see, okay, I have 2/3 and I have -3 over 2. Again, the signs are opposite and they're flipped, so I get perpendicular again. Here I have 6 and -6. The signs are different, but they're not reciprocals, so it's neither. Obviously, parallel, they're the exact same number. There's not really much for me to tell you other than that. But that's an example of a type of question you get asked from time to time about parallel, perpendicular, neither. We want to remember that parallel lines have the same slope, so they never touch each other. Whereas perpendicular, since they're opposite reciprocals, they actually meet, and when they intersect, they create a right angle. So that gives you a couple different things to kind of think about there. So along with that, let's go into talking about a problem that deals with parallel and perpendicular lines, but it's also going to cover that basis for point slope form where we get to see 2 points and then find the slope. At least I think that's what I want to do. my previous example at? Yeah, we can do that. Maybe. Let's not be too crazy. Okay. Also, if you have questions, remember, please ask in the chat if you have questions. If you're watching the VOD, shoot me a DM on Twitter or hit me up on YouTube where these will be posted on my channel. So, which I guess I should link it somewhere. Good thinking. Anyways, example. Given y is equal to 4/5 x minus 3, find a line perpendicular that passes through the point of 5, 10. I think that might work out. Okay, we'll find out. Okay, so we look at our original function here, and we see our slope, our original slope, m1, is equal to 4/5. All right, we need to make sure that we're looking at this word over here, and it says perpendicular, because I can't tell you how many times I have students read through, and they skip that part, and they're like, oh, it's parallel, and they move on. They get the problem wrong. All right, so we need an m2. Our m2 is going to be -5/4. Okay, nothing too terrible, but at least we can use that. So after we have that part, we have our x1, y1 over here, and we have our slope. So then we're back to point slope form. So y minus 10 equals -5/4 x minus 5. This is why I don't make up problems, because it always goes bad, but that's fine. We're going to work this out. It's going to be nice. Okay. Let's deal with what's over here first. Let's leave this y minus 10, because I want to actually show something that I think makes things quite easy. And we get -5/4 x plus 25/4. Okay, we haven't solved for y yet, and that means we need to come over here and we really need to think about this plus 10. Now what I suggest is go ahead and change this to a fraction here to bring it over. So if I need this to be over 4, let's say thing is saying plus 40/4, because 40 divided by 4 is 10. And we come over here and say plus 40/4. All right, that way in the grand scheme of things, we get y equals a -5/4x plus 65/4. Okay, that problem's kind of convoluted because of the fact that we used fractions in perpendicular, but that's what we wanted. We wanted a line perpendicular that passes through that point, and we found it. So let's go through and say, hey, what if we want to find a line parallel? Well, that's going to be even easier for us, which is great. So let's look at that. So, in fact, let me use the same type of format as the previous problem. Okay. Given y is equal to, let's do something a little bit more simple this time, -6x plus 3. Find a line, it looks like it says line, but it's definitely line, parallel and passes through the point what do we think in the chat? How about -7, 2? Well, I guess it's going to be -2, 7 because I messed that up. Anyways, so we go back to the same thing. You need to read the problem. I always tell people, when you see anything that has words in it for a math problem, you read it, you go back and analyze it, then you solve it. So I've already read through it. We're going to analyze it for information. we know this is our function that we need. And when we look at that, we say, okay, well, m1 is equal to negative 6. Awesome. Find a line parallel that passes through the point negative 2, which is x1, and 7, which is y1. All right, again, we're dealing with parallel and perpendicular, so we need to think about what is m2? Well, m2 is going to be parallel, so it's the exact same slope. Nothing changes. And I already have my x1, y1. Again, we go back over here and we say, okay, well, y minus 7 is equal to negative 6x, which is going to be plus 2 because two negatives make a positive. All right, then we can go through, we can start solving some stuff. Y is equal to, let me go ahead and write this out over here so we don't get lost in the sauce. Plus 7, so no one gets utterly confused what happened to that. Negative 6x minus 12, and then I like to bring that over and just say plus 7 to cut out a step. And we get y is equal to negative 6x minus 5. All right, again, boom, parallel. You could graph that. It would not be a big deal. It'd just be like we did earlier. If we want to look at that, let's go ahead and do it. Why not? Come over here and we graph. Get our nice looking coordinate plane. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So we know we're going to go down at, and we're going to be at negative 5. So 1, 2, 3, 4, and 5. Again, remember, this is a negative slope, so it should be going downwards left to right. So we're going to go up 6. 1, 2, 3, 4, 5, and 6 over 1. And then we're going to go up 6. 1, 2, 3, 4, 5, and 6 would be so much over here, and then we'll do over 1 more. So we get this nice looking line that goes like this. If I did hit the points. Wow. Oof. That is a big oof. Okay. Anyways, you guys get the point. All right. That's as simple as I can make graphing linear lines and going through their different linear forms. I really appreciate y'all coming out tonight to participate in this. If you ever have questions, please let me know. I'm always happy to answer them during the stream. I'm also happy to answer them via DM. You can hit me up on Twitter. It's at Blaze McBain there. I'll also find a link and link my YouTube, but you should, if you look for Mathman Mondays, you'll find it on there. And I uploaded last week's video. I'll get this one uploaded hopefully tonight, if not tomorrow. And I'll link that on Twitter as well. Next week will be an ACT prep week. I'm not sure if we're going to talk about strategies about to solve for the ACT or kind of what we're going to do yet, but I'm going towards an ACT-oriented idea since the 14th is the ACT day. I really appreciate you coming out. If you enjoyed the content, please hit the follow button. And again, any questions, concerns, criticisms, always happy to hear them. But I really appreciate y'all coming out and watching. And I'm going to switch over to a game.